All right, so here we go with lesson 6.3. And 6.3 is still working with exponents, as we've seen in 6.1 and 6.2. But now we're going to be looking at how these expressions with exponents behave on a graph. So there's going to be a lot of graphing over the next couple of lessons. To start with, let's put our name in the upper right-hand corner. We always want to make sure we have our names on our papers. Alright, so exponential functions. What does that mean? An exponential function occurs when x is the value of the exponent. And so you're going to see different types of equations, but the only exponent you're going to see is represented by the variable x, which means that it can change. It can be various numbers, which are going to be the x values that we plot on our graph. And then when we calculate those x values, it will produce the y values that we put onto our graph. And so when we do an exponential function, it's going to be a curved graph. Earlier in the year, we did linear functions, which meant it just created a line. Well, now we're not going to be making lines, we're going to be making curves. And so the resulting graph is either a curve going up and right, or it's going to still be down to the right. So much like when we say read graphs from left to right, that will still be happening with exponential functions. There will just be a curve. And so your exponential equation is y equals a times b to the x power. The a value represents your initial amount, also known as your start value. Now there's going to be times when you're going to see an equation that doesn't look like the a value is there. Well, that would just imply that the a value is 1 because it's being multiplied by b to the x, and anything times 1 is itself. So if it looks like the a is not there, we just know that it's 1. Now the b, well, that is your base. It's the number that is being taken to the x power, and of course then the x power, we call that our exponent. So an initial value times the base, and that base is taken to the exponent. There may be times where you will see the b in parentheses, just to remind you that it's only the b that's being taken to the x power, not the entire equation. So the a is not taken to the x power, only the b. b is the base. And so there's going to be two types of graphs we're going to see. We're going to see one that's called exponential growth, and we're going to see one that's called exponential decay. With exponential growth, it's just that the graph is growing in a positive direction, which means it's going to be going up and to the right. So for just a generic looking exponential growth, I'm going to put my y-intercept here at 1, and then the graph will look something like this. We'll get to the equations that make these graphs in a little bit, but the key is that it's moving to the right, and then eventually it's going to exponentially grow up and to the right. And so what would down and right to the b, or what would that look like? Well, if we have the same y-intercept here, now what it's going to do is it's going to come down like this, and then flatten out right here. And we'll talk a little bit more about these graphs in a second, but this is, in general, what your exponential graphs are going to look like. You're going to have one moving up and to the right, and one moving down and to the right. Now the next part of the worksheet here is we're learning how just to evaluate an exponential function. And so as we evaluate, all that means is we're going to replace the value of x with the given value. So this would be like one specific point on the graph. So if I'm saying that x is 5, I'm plugging 5 in for x right here. So my new equation becomes y equals 3 to the 5th power. So this would mean that when x is 5, y is the resulting value. Well, 3 to the 5th power, and you can use your calculator, 3 to the 5th power is 243. And so what do these numbers mean? For this specific function, this would mean that when x is 5, y is 243. That would be a point on the graph. And I'll go ahead and write that point on graph. Now there will be a lot of different points on these graphs. This is just one of many points. As we look at the next one, you have y equals 1/4 to the x power, and we're going to replace x with 3. So if I go y equals 1/4 to the third power, what does that mean? Well, just like we learned in properties of exponents, that means it's the numerator to the third power and the denominator to the third power, and this all eventually equals 1/64. So if you think about that in terms of on a graph, this would be the point that when x was 3, which is what we started with, this produced a y value of 1/64. And notice that that's a really small number. And we'll come back to how we know if it's going to be a small or a big number in just a second. The third one we have, now we have that a value. So this time the a value is 3. Over here, it's like there wasn't an a value there, so it was a 1. It's like it wasn't an a value here, so it was a 1. 3 was the base. 1/4 is the base. Over here, 4 is the base. 3 is the a that happens in front. So y equals 3 times 4 to the 4th power. Notice only the 4 is to the 4th power. You do not multiply this 3 times this 4. Do not do that. You have to do 4 to the 4th power first, then multiply that by 3. So it's going to look like y equals 3, and then 4 to the 4th power. Again, use your calculator. That's 256. So now we multiply these two numbers together, and you end up with y equals 768. So when x was 4, y is 768. All right, so at the top of the next page now, we're going to learn how we know if it's exponential growth or exponential decay. Here we have our exponential function, a times b to the x. Sometimes you'll see it as y equals b to the x, and that just means that the a value is 1. But the b value is what determines growth versus decay. So if the b value, the base number, is greater than 1, it's going to be exponential growth, meaning that it's going to go up and to the right. But if that b value is between 0 and 1, it's going to be exponential decay. Well, if you have a number between 0 and 1, that means it's going to be a fraction. So if the fraction that we put in for b is like 1/2, 1/4, 2/3, any fraction that falls between the values of 0 and 1, it's going to be exponential decay. All right, so now let's do some practice graphs, just so we kind of get used to what an exponential function is going to look like. All right, so the first one we're going to do, and you're going to write it in this top blank, we're going to do y equals 2 to the x power. Now the way we're going to graph this is we're going to pick values and plug them into this equation. And we're going to make what's called a table of values. So a table of values, it can also be known as a t-chart, looks like this. You draw that, you make an x over here and a y over here. And we want to pick numbers that are easy to work with. Well, the 5 easiest numbers to work with are -2, -1, 0, 1, and 2. And we're going to plug each of these in one at a time to x right here to produce our y values. And then we're going to have 5 xy coordinate points that we're then going to put over here. Okay, so as we fill this out, think to yourself, all right, I have y equals 2 to the -2, which turns into 1/4. I have y equals 2 to the -1, which turns into 1/2. I have y equals 2 to the 0. Remember, anything to the 0 power is 1. Then I have y to the 2 to the 1 power. Well, that equals 2. And then I have y equals 2 to the 2nd power, which equals 4. So these numbers right here, I'm now going to put over here as my y values. So I have 1/4, 1/2, 1, 2, and 4. And what you'll notice is, from each y value, what's the jump here? We're multiplying by 2 to get from here to here, or from here to here, from here to here, from here to here. And we're going to keep multiplying by 2 because my base is 2. So now when I graph these, I'm at -2, 1/4. -2 on the x-axis, up 1/4 on the y. That's barely up. barely. And then I go -1, so that's left 1, and then up a half. We're still not growing very much, but then if we go 0 and 1, that's right here, and then 1, 2, that's right 1, up 2, and then right 2, up 4, 1, 2, right, 1, 2, 3, 4, up. And then, just to kind of show you how quickly this happens, what if we added a 3? Well, that would get us to 8. And now we're at 1, 2, 3 to the right, 1, 2, 3, 4, 5, 6, 7, 8 up. And now you start to see the growth. So the points are really close together, but then they quickly grow as x gets bigger. So if we had made x 4, it wouldn't even have fit on our graph. Or if x was 5 or x was 6, it wouldn't even fit on our graph. The last part of exponential function is understanding the domain and the range. Now we did talk about domain and range earlier in the year. Domain, you see these words up here in bold, domain are the x values and range are the y values. So we're trying to determine from this graph, what are all the possible x values? Well, this graph right here, it's going to continue to go left forever, which means I can keep going left and left and left on my x-axis. As I come back to the right, I can keep plugging in any x value that I want here, which means that my domain or my x values, I say, are all real numbers, because I can pick any positive x or any negative x that I want. But for your range, your y values, notice that as this curve comes down, it's going to flatten out. It's never actually going to reach 0 on the y-axis. It's never going to touch the y-axis. It's going to hug it, basically, go right along it, but it'll never actually come in contact with 0. So the graph will never go down in this area. So the only y values that exist are y values that are greater than 0. Okay, now we're going to look at an example where the b value is between 0 and 1. So my equation is going to be y equals, and now the b is going to be in parentheses because it's a fraction, to the x power. Remember, the exponent's always going to be x. We're going to change the base and later change the a. The a value right now is just 1. It's just 1. So I need to make another table of values, or a t-chart. And so if I go x and y, I'm going to pick the same ones, -2, -1, 0, 1, and 2. Now for these ones, if you imagine them one at a time, you got to put -2 right here. Well, if this was -2, it's going to look like this. 1/2 to the -2 power. Well, we don't like that. We don't like negative exponents, remember. Well, the way you change this into a +2 is you flip the inside, and now that is to the +2 power. Well, that's just 2 to the 2nd power, which is 4. And then what happens is, where this one over here multiplied by 2 each time to get from one y value to the next, well, now what do you think we're going to do? Well, now if we're decaying or decreasing, because my b value is between 0 and 1, now these numbers are going to divide by 2 each time. So this will be 2, this will be 1, this will be 1/2, and this will be 1/4. And notice how similar these tables are, except these y values are increasing by a multiple of 2 each time. These ones are decreasing by a multiple of 2 each time. So now I'm going to graph these 5 points. So here are the 5 points, and as I connect them with my curve, now they still fall along the y-axis like they did before. My domain is still all real numbers. And my range, my y values, everything's still above the y-axis, so that means when y values are positive, so it's still y is greater than 0. So we're going to stop right here for the first video, and then you'll go ahead and go back in the classroom and click on the second video.